Hi, I'm Lisa Charleyboy, and today I am here at Osum Oil Sands Corp, and I am talking to Dr. Jen Russel-Houston, who is the Manager of Geosciences here at Osum. Tell me, what does a Manager of Geosciences do?
So I lead a team, a wonderful team of people who are geologists and geophysicists, and they study the ground, the earth. And really what we're doing is looking for oil, and we're looking for water. So that's what our team does.
Okay, fantastic. So I've been really curious about the Cold Lake project, the Taiga project, and I'm interested to know a little bit more about where the water is coming from, because I hear there's no fresh water that's going to be used. So I want to know a little bit more about what the process is like and what it looks like. And I need you to tell me in really layman's terms, because I, unlike you, am not a scientist. I haven't taken any science in high school, so you gotta...
Okay. Stop me if I use a word that you don't understand then.
Okay.
Geoscientists, we're famous for using words that no one understands, except for other geoscientists. So
okay.
All right. So the team would build an understanding using wells and seismic of what's beneath the ground. And this, what I've put here on the board, is a picture of then what we would develop. Right. So we know that the Earth has some layers within it,
right,
and those layers have different types of rocks. And so for water, this becomes I got to tell you, as much time thinking about water as I do about the oil. Because for a steam project, we need water.
Right.
And one of the challenges our engineers gave the geoscience team at the very beginning of the project was find us brackish water. Fresh water is drinkable. And there's a certain range where it stops being fresh and you start to call it brackish.
Okay.
And brackish just means you taste a little bit of the salt, and it would be bad for you to drink. So it's we call that non-potable. You can't drink the water.
Okay.
And that's what the team said to us. They said, find us brackish water. And of all the wells I drilled in 2008, the hardest and the ones I lost the most sleep over was finding the right water source. And we found it. And the source of our brackish, this is this well right here. Mm-hmm. And this is a model of the subsurface. This zone right here is the McMurray. And it's the same McMurray formation that's up further to the north has oil in it.
Right.
In our area, it doesn't have oil, it has water.
Okay.
And this is 600 meters. This scale from surface to ground, this is the surface. There's my little trees.
Yeah.
Put a little person on top. And this is 1,200 meters down to the bottom. And when we hit 1,200 meters, this is really old rock. This was Precambrian. It's about 600 million years old.
Okay, I was just about to ask that.
Yeah. So really old rock, and that's there's never any reservoir below that.
Okay.
It's the same stuff you'd build your counter out of, right? No porosity, no pore space. All of these other zones might have pore space. And pore space is just, in the sands, you have grains of sand. So if I took a little piece of this and blew it up to this, you'd have little grains of sand. And all we're talking about is the pore space and the space between the grains. And that can either be filled with oil, it can be filled with gas, or it can be filled with water. And once we find it and find the water and produce the water out, we're going to have a great production, which means the water will come out and the sands of grain stay there and they continue to hold the rock out. So one of the concerns people have...
So it's not going to collapse?
Yeah. One of the concerns people have is once you produce all this water, well, am I going to have trouble with things caving into the surface?
Right.
You won't, because it's the grains of sand that continue to hold up the rock.
Okay.
But let's just talk about depth. I always make sure people understand how deep this actually is.
So 1,200, that's feet or meters?
So this is in meters.
Okay.
And meters means, so that's a kilometer and a bit.
Right.
Down. And to put things in scale, the Calgary Tower is almost 200 meters tall. It's 191 meters tall. So that's the Calgary Tower right there.
What about the CN Tower? No, just kidding.
Calgary Tower reference?
Calgary Tower is a great reference.
All right. One other thing people like to know, the deepest lake in the area is Cold Lake.
Yes.
All right. So if you think about where Cold Lake is on our figure, Cold Lake doesn't even make it out of this first brown zone.
Okay.
And that brown zone is representing the youngest rocks in our stack. And these rocks are about 25,000 years old. And then there's a big jump from these rocks to the next set of rocks, and these ones are about 55 million years old. Okay, guys, a big jump.
Okay, and what's this one for?
Right. Okay. So brackish wells. When we build the facility, why the engineers said we need water is we have to make steam. Okay. So once we're up and operational, the way this works, we put the steam into our production well. And the production, this is to image where our reservoir is. And our reservoir is about 500 meters down. Okay. And we put the steam in because we need to move the oil. The oil doesn't move on its own.
Right.
So we want to melt it. It's just like Hershey's chocolate. We need to make it move. So we melt the chocolate, we melt the bitumen, and it comes back out. And as it comes, it brings a little bit of the formation water. So in our pore space, we have a little bit of oil, and we also have a little bit of water. So it's going to bring both of those with it.
Okay.
And it also brings back the steam. And that's great. So we bring it back to our plant. And they like to think of their facility as a water plant. And the byproduct of the plant is bitumen, oil. So all the work that goes on here is to clean that water up. Produced water, we recycle it, and then we can put it back as steam. But to get things going, we need water to begin with.
Right.
Right? And
So
that's where the
it comes from
brackish
here.
water comes from.
Okay. I'm still confused about this one though.
Right. Okay, so we bring this brackish water up.
Yeah.
We produce the steam. Everything's working great. In order to clean the brackish water and make it good for steam, it has to be fresh.
Okay.
And we have to get rid of the salt. And in the process of getting rid of the salt, we get a sludge. We've decided to keep everything contained in our project and have the disposal on site. And so one of the things we're going to do once we get approval is a well that will come down to this zone, which is salt. This is a layer of salt that's about, I think it's about 500 million years old. So what we're going to do is take the brackish water and we put some of it in here to this salt well, and we just start washing it, and we melt the salt, and we're going to create a salt cavern.
Okay, great. I've heard about the salt cavern. So now I can get a great visual about where it is and
Yeah, the salt cavern
there.
is about 1 kilometer down. So we're going to then, with our facility, the water facility, we're going to have some sludge. So we're going to put that into the salt cavern.
Okay.
And the salt cavern, it's going to layer up, the sediments go to the bottom. There's going to be some water up at the top. It's not water that we want to touch our brackish well. It's not water we want to touch into the shallow zone. We need to get rid of it. Okay. And so we are lucky in that we've found, again, a zone for deep disposal.
So there's no tailings pond?
No.
Anywhere?
No.
And all of the excess things are being held here?
Right.
And so there's no trucks taking it off somewhere?
That's part of keeping everything contained, is that we
Great.
don't have to use trucks.
Oh, great. Thank you so much for taking the time to explain this to me. I think I get a clear understanding of what it looks like underground and where everything is going. So I greatly appreciate it.
Good. No problem.